Welcome back, students, to ECN 236 class. We are still looking at sampling theory, elementary sampling theory. In the first video, I defined what sample is, and we look at the reason why we sample, that is the purpose of sampling. Today, we want to look at sampling process. What are the processes involved in sampling? There are 5 processes involved. The first one, we have to define the population of interest. We must know the population from which we are sampling. That's the first step. When we know the population of interest, second one, we specify our sampling frame. When I say sampling frame, it's just the list of elements of the population. That is sampling frame. After knowing your population of interest, that so maybe in Alimosho local government is my population of interest. I want to count the number of houses in Alimosho local government. That's your population of interest. The sampling frame, we have any list of the houses, the street by street, so or town by town. You have to know the sampling frame, just the list. Sampling frame is just a list of elements of a population. It can be your electoral register, it can be telephone directories. Those are what we call sampling frame. Number 3, we have to specify the sampling method. Which method do we want to use for sampling? There are different methods of sampling, which we'll get to later. We want to know the method we want to use for sampling. Is it simple random sampling we want to use? Is it systematic sampling? Is it quota sampling? Is it accidental sampling? We must know the sampling method we want to use. That's the third one. The fourth one, you must know your sampling size. The sample size you want. What the size of the sample you want to select from your population. So after knowing that, then you carry out your sampling plan. How do you want to plan for the method you want to use? So those are the sampling processes. So there are 5 sampling processes which you have mentioned. Now we look at the sampling theory. Sampling theory is a theory that explains the relationship between the sample statistic and the population parameter. So sample statistic, when we say statistic in this context, we are only talking about the descriptive measures of the sample. Like you find the mean of the sample is a sample statistic, we call that one X bar. You find the variance of the sample, that's S square. Those are the sample statistics. You find the standard deviation of the sample, that's a small s. Those are the sample statistics. Population parameters, they are the descriptive measures of the population. In this case, we'll be talking about a population mean, which is mu, population variance, which is sigma square, population standard deviation, which is sigma. So it is the sampling theory that explains the relationship between the sample statistic and the population parameter. It is also used to determine whether the observed differences between 2 groups as a result of a chance variation, or whether the differences are really significant. What do I mean by this? If they are used 2 different methods to carry out or to test, 2 different methods to produce maybe an item, let's say to produce a drug. So after producing drugs, you use two different methods. You take some sample from the first, let's say the method A, method B. So you take some samples from the drugs you produce using method A. You take some samples, the same, let's say the same sample size, from the drug you produce using method B. So you now test. You want to know whether there are differences between the two drugs. So maybe it's the weight. You weigh it, you find the weight of the average weight of the first one or the other one, or you are just testing for differences. It is this sampling theory that let us know whether the differences between the two methods are really important, or whether one method is better than the other, or the differences between the two methods only happens by chance. That is what sampling theory. That's what sampling theory does. Now we want to look at basic principles of sampling. Basic principles of sampling. We are going to look at two different laws. The first one is the law of statistical regularity, while the second one is the law of inertia of large numbers. Law of statistical regularity says that if you choose large number of items at random from the large group, those large number of items we choose from the large group are almost sure the average to possess the features of the large group. There is only saying that your sampling must be random. So if you have a large group and choose a very large items from the large group, then on the average, those large items you chose from the large group will possess the features of the large group. That's what the law of statistical regularity says. Then the law of inertia of large numbers says that other things being equal, the larger your sample size, the more accurate your result will be. This one is just telling us that for you to get accurate results, for your sample to be a representative of the population, for you to be able to generalize your sample on the population, then your sample must be large enough. That is what the law of inertia of large number says. Now I want to look at advantages of sampling. It's almost the same with the purpose of sampling. Number one is economical in nature. There is shorter time lag because the time you use to collect information from sample at least be shorter than the time you use to collect information from the whole population. There is a greater scope. There's greater scope, actual appraisal of the reliability and high sustainability ratio. So we have come to the end of the class. By the next time we'll meet, or we're able to post videos, we'll continue from where we stopped. Thank you for listening. God bless you.